Welcome to your finite math, part 2, day 2 of section R3. And today we're going to be talking about rational expressions, but we're going to be talking about addition and subtraction with rational expressions. So we're going to simplify rational expressions with addition and subtraction. Remember, rational expressions are algebraic fractions, and so the same rules apply. You still need a common denominator to add and a common denominator to subtract. So that is going to be one thing that is a little different from multiplication and division, where you don't need common denominators. So remember, the addition property is just as long as you've got that common denominator that's not equal to 0, you can add the two numerators together and use the common denominator. If you're subtracting, you use the common denominator and you just do the first numerator minus the second numerator. Okay, so let's just get started with examples. We've got 3 over p plus 1/2. So we need a common denominator, and we want the least common denominator. So you always include all factors of the first denominator, so p. And then you multiply by any new factors in the second denominator. Well, 2 is new, so we're going to have p times 2, or 2p, for our least common denominator. Okay, so the 3 over p, we need to multiply on top and bottom by 2. And then the 1/2, we need to multiply on top and bottom by p. And so we end up with 6 over 2p plus p over 2p. And at this point, you go, great, I've got my common denominator, so I'm going to use it, and I'm going to add my numerators together. So I use the common denominator of 2p, and I actually perform the addition with the numerator, so 6 plus p. And let's see, we usually write p before 6 in our terms, and so we'll write it as p plus 6 over 2p. At this point, you're looking at, since there's an addition or subtraction in the numerator, you ask, well, can I factor it? Nope, I can't. So if you cannot factor, you cannot cancel. So you've got to factor first and then cancel. So we can't cancel anything here, so it's our final answer. Okay, we've got a plus 1 over 2 minus a minus 1 over 2. We have a common denominator, so we can actually go ahead and do our subtraction, because our least common denominator is 2, and both fractions have a 2. So we're going to do a plus 1 minus all of a minus 1. Okay, so it's a plus 1 is our first numerator minus a minus 1 our second numerator. So we're going to need to distribute that minus through a minus 1. So it's going to be a plus 1 minus a, and then minus 1, or minus negative 1 is plus 1. So we end up with a minus a, which is 0. 1 plus 1 is 2. Well, 2 over 2, that's just equal to 1. So we just reduce it down. Okay, on the next one, we've got 4 over 3 times x minus 1 minus 2 over 5 times x minus 1. So we need a common denominator. Let's see. The first denominator here is in factored form, which is really nice. We can see we have a factor of 3, so we need that. And we have a factor of x minus 1, so we need that. Then we move to the second denominator, and we multiply by any new factors. So we look at the second one and go, okay, there's 2 factors here, 5 and x minus 1. The 5 is new, so we're going to have a factor of 5. The x minus 1 has already been covered. We've already got that, so we don't need another one. So our least common denominator is going to be 3 times x minus 1 times 5, or 15 times x minus 1. Okay, so now we need to rewrite our original fractions in a form that has the least common denominator. So let's see. The 3 times x minus 1 is missing the factor of 5, so we need to multiply on bottom and top by 5. And the 5 times x minus 1 is missing the 3, so we need to multiply in the denominator and the numerator by 3. So let's see, 4 times 5 is 20, and then 2 times 3 is 6, and we have our 15 times x minus 1 as our common denominator. So now we're ready to write this as a single fraction using the common denominator of 15 times x minus 1. On top, we're going to have 20 minus 6. 20 minus 6 is 14. 14 and 15 are relatively prime, so we're done. There's no way that we can factor something out and cancel. Okay, we've got 13 over 3m minus 2 minus 4 over m. So let's see. We factor if we can, but 3m minus 2 is prime, so there's nothing to factor there, and m is prime. So our least common denominator is going to be the 3m minus 2 as the factor, and then the m, because we don't have a factor of plain m yet. And usually we write m first, then m times 3m minus 2. Okay, so our first fraction needs to be multiplied on top and bottom by m, and our second one needs to be multiplied on top and bottom by 3m minus 2. So we'll have 13 times m, so 13m over m times 3m minus 2, minus 4 times 3m minus 2 over m times 3m minus 2. Let's go ahead and write it as a single fraction. So we've got 13m minus, see there's the minus, 4 times 3m minus 2 over our common denominator of m times 3m minus 2. So let's simplify the numerator. There are pluses and minuses outside of parentheses, so this has not yet been simplified. We haven't actually done the subtraction. You need to completely simplify the numerator and then see if maybe you can factor it. Okay, right now it's not in factored form yet. So we need to distribute the minus 4. So we're going to have 13m minus 12m. Negative 4 times negative 2 gives us plus 8. 13m minus 12m is m plus 8 over m times 3m minus 2. We look up here and see if the m plus 8 can be factored. It can't. So the m plus 8 is a little married couple, so we can't cancel it with the m, and it doesn't match up the 3m minus 2, so we're done. Okay, so now we've got x minus 2 over x squared plus x minus 2 minus 1 over x squared minus 5x plus 4. So we've got really complicated denominators. Now, we could just do x squared plus x minus 2 times x squared minus 5x plus 4, but we're going to end up with something that's just a hideous mess if we do that. Remember, we want the least common denominator. So what you have to do is you have to factor both denominators so that you can see what the individual factors are, so that you keep your denominator as simple as possible, because we want the least common denominator. Okay, so I need to write x squared plus x minus 2 in factored form. So I'm going to have x minus 2 over x plus 2 times x minus 1. So let's just double check. X squared minus x plus 2x gives me plus x. 2 times negative 1 gives me minus 2. And then I've got my minus here, and I've got the 1 over, and let's see, x squared minus 5x plus 4 is x minus 1 times x minus 2. Let's just double check. X times x is x squared. Negative 4x plus negative x is negative 5x. Negative 1 times negative 4 is positive 4. Okay, so since we can see what the factors are now of the denominator, we can figure out what the least common denominator is. So you include every factor of the first fraction. So we definitely have to have x plus 2 times x minus 1. And then you add into, or you multiply by any additional factors that you come across in the second denominator. So I have an x minus 1, but I already have an x minus 1 included, so I don't need to put another one into the least common denominator. I have x minus 4, I don't have that yet, so then I put in another factor of x minus 4. So my least common denominator is going to be x plus 2 times x minus 1 times x minus 4. Okay, my first fraction does not have an x minus 4 in the denominator, so I need to multiply by x minus 4 on the bottom, so I have to do that on top. My second fraction does not have an x plus 2, so I need to multiply by x plus 2 on the bottom and x plus 2 on top. All right, when things start getting really complicated, it's very important that you really think about what you're doing. I need to multiply x minus 2 times x minus 4. So that means I need to put parentheses around the x minus 2 times x minus 4, and it's over my common denominator there. And then I have my minus, and I'm going to have 1 times x plus 2 over my common denominator. Let's go ahead and write it as one fraction. So I have x minus 2 times x minus 4 minus 1 times x plus 2 all over my common denominator. Now on top, this is not in factored form. We haven't actually done this subtraction yet. We've got to multiply together the x minus 2 times x minus 4. We've got to distribute the minus 1 across x plus 2. We've got to combine terms. Then we are going to factor. Sometimes because there's so many parentheses, people think that this is in factored form. It's not, because you've got a minus here that's outside of parentheses. Okay, so you're not ready to cancel yet. It's tempting, but you're not ready for it. All right. So I'm going to FOIL the x minus 2 times x minus 4. So that's going to give me x squared minus 4x minus 2x plus 8. I'm going to distribute across that negative 1, so that's going to give me minus x minus 2. Okay. Now I want to combine like terms and see what I get. So I'm going to have x squared, and let's see, negative 4x minus 2x is negative 6x, minus another x is negative 7x, and then 8 minus 2 is 6. So now I've got a trinomial, so I want to factor that. So let's see, negative 6 times negative 1 will be 6, negative 6 plus negative 1 will be negative 7. So I can factor x squared minus 7x plus 6 is x minus 6 times x minus 1. Now, if you notice, x minus 1 on top matches with x minus 1 on the bottom. So those cancel out to give us a 1, and so we're left with x minus 6 over x plus 2 times x minus 4. And that's all we can do, because remember, these are little married couples, and it's all or nothing. They have to match up and make a 1 together, or you don't get to cancel them at all. So our final answer is x minus 6 divided by the product of x plus 2 times x minus 4. Okay, guys, you're used to this part of the video. Please make sure you do the problems to try on your own. If you can't do them, then you need to either go back and rewatch the video, or you need to get with me or a peer tutor and go back over the examples to where you can at least attempt the problems to try on your own. And we'll go over them whenever you get to class. Okay, guys, have a good day. I will see you soon.